All right, I think we're recording. Let me go ahead and make this a little smaller. Um, I snuck out on my wife this morning. I'm actually wearing linen after Labor Day. Just because it's going to get up to 92 today. But anyway, and, and it's going into the dirty clothes, and it's going into the dry cleaning and to be hung up until next spring or next summer. Um, anyway, the next two chapters, 17 and 18, tie together very, very nicely. All the concepts you've been doing electrostatics over 16 and 17. Kind of you've been learning the theory behind electricity. Okay, not magnetism yet. We learned that in chapter 19. So we're going to do. Um, so I think your first example, we'll introduce a little bit of magnetism into it, because we're moving pretty quick. This new method that I have, I'm teaching it to you now, or giving you guidance. I don't know how well we're teaching it. You never know how well you're teaching anything. So but actually you do. But anyway, so these next two chapters are going to be kind of a breath of fresh air after those first two very highly theoretical chapters that we did. Okay, and I've got the PhET simulators loaded up here. So without further ado, let's go ahead and get started with the. I'll log off here with the slide, with a little bit of the slideshow where we start with batteries. All right, so here we go. Got our batteries here. Let's go to the slideshow, current slide. All right, here we go. Now, I showed you a little thing earlier on how the battery works. You got the anode side and the cathode side. Notice the anode is the positive side. And pretty much what we have is we have less negative charge here, so it's the positive side, and more negative charge over here. This would be like so if this is a 12 volt battery, we could say this is like -4 and this is -16 coulombs or something like that. So you get that change in voltage difference. And we've already seen how a battery is a source of electric energy. It converts chemical energy into electric energy. Wow, does that sound like a great conceptual question to me? What does a battery do? Okay. All right, now, in a complete circuit, electrons flow from the negative electrode to the positive one. The positive electrode is called the anode, the negative is called the cathode. A battery provides a constant source of voltage. Okay, it maintains a constant potential difference between its terminals. Now, if you buy, what we're going to find out is when you buy a 12 volt battery, if you have a little 12 volt or 9 volt battery, what happens though is actually there's internal resistance to that, so it might only produce like 11.6 volts or something like that. But we'll get to that. Now here's another big term. When the battery is not connected to anything, it is called the potential difference between the battery terminals when the battery is not connected to anything is called the electromotive force, the EMF. All right, and it's written with a fancy E. Fancy E, same thing as V. Okay. All right. Now, the actual terminal voltage of, okay, I always get ahead of the slides, is always less than EMF due to the internal resistance. Usually the difference is very, very small. So I've got this internal resistance here. I've got this my 12 volt battery, but the overall V is going to be like 11.6. And what I'm going to do is I'm going to write that out mathematically for you here in a minute. In fact, right now. So we've had our little introduction. And we only have, this is a perfect chapter for when we only have a 2-day week, because this is a perfect 2-day chapter. Okay, so this is the end of lesson 1. Let me get to it. Here we go. Turn this off.